Today we are going to start group 15 elements. Group 50 element, because group 13 and group 14 are there in your class 11 syllabus. So now what are the elements? Elements are, we know, nitrogen, phosphorus, arsenic, antimony, and bismuth. So what is their general electronic configuration? It is NS2 NP3, or I can write it in this way. Why? Because it's half-filled electronic configuration. So better to write like this: NPX1, NP11, and NPZ1. See, it is group 15. Outermost electronic configuration is 5 electrons. See here, 2 plus 3, 5. Then please remember, 15 minus 5 is 10. So where the 10 electron goes, 10 electrons is present in their n minus 1 d orbitals. So this is the advantage of remembering the electronic configuration of the group 15, sorry, p block elements. What is the group? What is the group number? From there you subtract 10, and rest you write it in the S and P block. You know, maximum electron accommodated in S orbit will be 2. So 15 minus 10 is 5. So it is NS2, then NP3. Okay. Now we are going to discuss about this general. Generally we call it in group discussion, but in somehow it is not mentioned in your book, but in our college days we used to call it group discussion. That is, we are going to discuss all the elements of the same group together. So here we will go for now physical. So first of all, what we are going to discuss is the atomic and ionic. See here, initially one day I only spent on this. So now you know, group 15 elements, nitrogen, phosphorus, arsenic, antimony, bismuth, they are in the same column. So group 15 elements appear after group 14, before group 16, if I go in period. And we know, when you go along the period from left to right, the atomic radii and ionic radii decreases. So what I can write now here, I can write the atomic and ionic radii of group 15 elements are smaller than corresponding group 14 elements in respective period. Okay. So atomic and ionic radii of group 15 elements are smaller than corresponding group 14 elements in their respective period. Why? Why it is smaller? Because of higher effective nuclear charge. Because of higher effective nuclear charge. So it is along the period. But when I go down the group, it's the same group only. So we know when you go down the group, they will increase because you add extra shells. Atomic and ionic radii of these elements increases down the group due to addition of extra shells. So these are common. This is applicable for all groups. So you have, because of that, I spent one full day. Okay, now I told you that ionization enthalpy, electronegativity, electron gain enthalpy, all of them they depend upon atomic sizes. Atomic. So let us go for this ionization. Ionization enthalpy also increases from left to right. I'll write right here. Ionization enthalpy of these elements are higher than corresponding group 40 elements. Why? Because again, because of higher effective nuclear charge. Okay? Due to higher effective, same reason. But it is very interesting. If it is 15 is more than 14, then 16 should be more than 15. But we find no. That ionization enthalpy of group 15 elements are higher than group 16 elements. Okay? Right here. However, ionization enthalpy of group 15 elements where found to be more than corresponding group 16 elements. You know the reason? Reason is due to their more stable half filled. See, completely filled is 6. It is having 3. So more stable half filled p orbital electronic configuration due to their more stable half filled. Right now here NP3 electronic configuration. So this is important for your exam. It decreases down the group due to increase in their size.
Done, sir.
Okay, now next we will go for what? Next one we will go for electron gain enthalpy. See, electron gain enthalpy has nothing to deal with stable electron configuration. Okay, so it will be more than group 14 elements and less than group 16. And electron gain enthalpy is always expressed in negative. Electron gain enthalpy of group 15 elements. Sorry, dear, sorry. Brain is not functioning. The negative elements are found to be more than corresponding group 14 because we know it also increases from left. It decreases from Okay. Now we'll go for electronegativity. No, it's 4. The electronegativity of group of elements are more than same thing. Corresponding group for 10 elements. Why it is more? Because of higher effective nuclear charge. Because of higher effective nuclear, it decreases down the group due to increase in their size. Okay. See, now if I take both of them into consideration, what we'll find? That at the top, ionization enthalpy is very high. Electron and enthalpy is more negative. Electronegativity is very high. So all these things suggest us that these elements at the top, they do not like to lose electron, because to lose electron you require more energy, and they have large negative electron gain enthalpy. That is, they feel more happy to accept electron instead of losing it, and they always like to put bond pair towards themselves. So these are the property of non-metals. Non-metals generally do not form cations. Non-metals form an ion because their electron enthalpy is more negative. Non-metals has a tendency to pull electrons towards them. So if I bring all of them into together, then I get another property that is called metallic. Okay. Metallic property. So what should I write now here? The metallic properties of these elements increases down the group. Or what I can write here? That is non-metallic properties of these elements decreases down the group. See, nitrogen and phosphorus are purely non-metals. Then arsenic and antimony behave as semi-metals. It is they behave more as a non-metal, but they have a tendency to conduct electricity. This is the difference between metal and semi-metals. Semi-metals show more property of non-metal, and one property of metal they inherited is the electrical conductivity. While Bismuth is a metal.
Done, sir.
Oh. Now we'll go for melting point and boiling. The melting point increases from nitrogen to arsenic, and then decreases from antimony to bismuth. It is the increase, then the decrease. Boiling point of these elements increases from nitrogen to that I'm not mentioning the boiling point because it's not possible for you to remember also. Okay, done. Huh?
Yes,
Then
sir.
why you are remaining quiet? Allotropy. Now we should know what is called allotropy. Do you know the meaning of allotropy? Any one of you know? Do you tell me if you know the definition of allotropy? See, when I ask you why do you remain quiet, either you say yes or no. I'm really fed up. When I see the attendance, I found 12, 13, 14, 15 of you are there. But when I ask you, you did not never open your mouth. Do you know or you don't know?
I don't
Sir,
know.
it is the existence of more than one physical state.
Huh?
Sir,
I
it
could
is the existence of more than one physical state.
see allotrope is the same element existing in different forms. See, oxygen exists as O2, but oxygen also you can find in the O3. The names are different. These are the two of them are called allotropes. All these elements except Bismuth. So allotropes. See, nitrogen in gaseous state do not show any allotrope. Nitrogen in gaseous state does not have any allotrope. All the physical state of all allotropes are same. If one of them is gaseous, others also will be gaseous. If one of them is solid, others also will be solid. Elements which shows maximum allotrope is carbon. Carbon you can get in crystalline form as well as in amorphous form. In crystalline form, what are the allotropes you have? Diamond, graphite, and fullerene. All of them are crystalline. And in amorphous form, what you will get? You get carbon, coal, then gas carbon, there is soot. Okay, all of them are amorphous. Nitrogen in gaseous state does not have any allotrope. But in solid state, it has two allotropes. Okay, alpha nitrogen, this I have given for your entrance, and beta nitrogen. Phosphorus shows maximum allotrope.
Answer.
Okay. Now atomicity. It is how many atoms make their molecule. Atomicity. Nitrogen is a diatomic. Nitrogen is diatomic. See why? Let us see. It is because of its small size and effective P pi P pi overlap. Okay, I'll show you. See here. This is nitrogen atom. You know it is sigma bond that you have already done in class 11. See here. It is 2 pi orbital. And the size is small. The size is small, so they come very close and have a very strong overlap. See here. This. Overlap forming nitrogen triple. Now let us see the P. Next one is P. See here. Please remember, nitrogen has 2p orbital, phosphorus has 3p orbital. 3p orbitals are larger than 10 2p orbitals. As the 3p orbitals are larger, so the density of electron in those p orbitals are very less. So in that case, what happens? They cannot form effective p pi orbital. Because of that, triple bond does not form. So right, I write now here. In case of phosphorus, arsenic, and antimony, p orbitals are large and have diffused electron cloud. So, they cannot undergo effective p pi p pi overlap to form pi bonds. See, their valency is 3. So as they see here, nitrogen valency is 3 bonds. But as they cannot form triple bond, what they can do? So they have to attain their trivalency. Thus, in order to attain trivalency, they form bonds with 3 more atoms through sigma bonds and exist as P4, ASO4, and HB4. So, what will be there? See here, phosphorus, it cannot form P bond, sorry, triple bond, but its valency should be 3. See now what happens? So they join like this. So, in this case, atomicity is 4. Here, atomicity is 2. Okay? So, here, what we will write now here? Atomicity 2, and here atomicity is
Sir, what is that word? That the one after electron? Have diffused electron. That word after electron, sir.
yes, please tell me what happened.
Sir, the word after diffused electron.
Which one?
What is that
Electron
word,
cloud.
sir?
Oh,
Have diffused electron.
cloud. Sorry. CLOUD. So they cannot undergo effective p pi overlap to form pi bonds. Thus, in order to attain trivalency, they form bonds with 3 more atoms through sigma bonds, and exist as P4S.
Done, sir.
Okay. So let us go for it now. One word that you have heard it. It is called catenation. You know catenation? What is catenation? Do you know the word? Have you heard the word catenation? Hmm?
No, sir.
Catenation is ability to form chain. Is many atoms can join with each other. Okay, this is called catenation. See, carbon can form chain with thousands and thousands of atoms. So what should I say? Group 15 elements show catenation to a much lower extent. See, nitrogen joins with another nitrogen. Finish. But phosphorus shows the highest number of catenation in this group. Phosphorus can join with each other. Okay. So phosphorus shows maximum catenation.
Done, sir.
Okay. So here we can write. Now we'll come to chemical properties. Okay, so we'll go for now covalence. Nitrogen shows a covalency of 3, where others can have up to 5. It is because nitrogen does not have any d orbitals. This I'll explain later on when I go to the oxidation state.
Done, sir.
Okay, now we'll go for oxidation states. See, oxidation state is the charge, net charge on the central atom. So first I'll show you, then only I'll write. See, this is NS, NP, and P has 3 orbitals, D has 5. Okay. So our electronic configuration is this. Unpaired electron only take part in bonding. Okay. So now, in this case, the oxidation state of this electronic configuration will be either -3 or +3. Why? If nitrogen combines, yes. Hello. Now, if nitrogen combines with less electronegative element, then its oxidation state will be -3. And if it combines with more electronegative element, then it will be +3. So I'll write here oxidation state. It's just like that. Suppose you are standing along with a person who is shorter than you are taller. But if you are standing with a person who is taller than you, then people will say you are shorter. So I'll write here -3 or plus. So I told you, no, inert pair effect. But if the inert pair effect is less, what will happen? See here, this electron from here it can go here. So how many? Oh, sorry. How many you have an unpaired electron? 5. So this is plus. So what should I write now here? The elements in this group can show oxidation states from -3 to plus. Then I'll write next. We know when you go down the group, this, when you go down the group, this pair of electron does not break. We call it inert pair effect. So what should I say? The stability of yeah, that is +5. Oxidation state decreases down the group due to inert pair effect. Example, Bismuth generally does not show +5 oxidation state except bismuth pentachloride. Why? Chlorine is such a strong electronegative element, it robs its electron, it forcefully takes the electron. Otherwise, Bismuth does not show plus 5 oxidation state.
Done, sir.
Okay. Nitrogen shows maximum number of oxidation states. That is -3 to plus. Example, see here, NH3 minus. I think you still remember how to find our oxidation state. See here, NH3. It is A plus A and B. So here, what I write now here, A plus 3B is equal to G. Hydrogen is always minus 2, sorry, plus 1, 0. So A is equal to plus 3. So A is equal to minus 3. So this is the way we calculate. NH2, NH2. This is called hydrazine. This is minus. NH2OH, we call it hydroxylene. This is the ammonia, you know it. Okay, I'll write there now. Hydroxyl. This is minus. Let me find it. NH2O. See here. A 2 plus 1 3 plus this is oxygen C. See here. A, this is plus 3, oxygen is minus 2. How much it comes? 0. So A plus 1 is equal to this. So A is equal to this. N2 nitrogen gas. 0. Then N2O. This is called nitrous oxide. It is plus 1. Then NO. This is called nitric oxide. This is plus 2. Sorry. N2O3. This is called dinitrogen trioxide. I'm writing only for your entrance exam. Plus 3. NO2. This is called nitrogen dioxide. And N2O4. This is called dinitrogen tetroxide. This is plus 4. And N2O5. Dinitrogen hydroxide plus 5. Now, why does it happen? Why nitrogen shows? Phosphorus also, sorry, let me write here. Nitrogen shows more oxidation states due to its small size, high electronegativity, and ability to form pi bond with oxygen.
Done, sir.
Done, sir.
Okay. All the oxidation state of nitrogen from +1 to +4 are not stable and often undergo disproportionation. Means they break down to give you two stable oxidation states. Okay, this is important for your exam. Say here nitrous acid. What is the oxidation state here? In this case, it is fine. You will find it is +1. No, sorry, +3. So if you heat it, nitrous acid is not stable. It will give you HNO3. This is +5. NO +2 and H2O. If you heat it. Same thing happens with phosphorus also. Phosphorus sorry. This is called nitrous acid. This is nitric. Same thing you'll find. H3PO3. This is called phosphorus. Okay. So if you heat it, it undergoes disproportionation to give you 3H3PO4 plus pH3. This is called phosphoric acid. And this is called phosphorus. This is plus 3. This is plus 5. This is minus.
So,
Hmm.
Done, sir.
Voice is not clear. Break.
uh,
Tell me.
I don't understand the term disproportion.
Not disproportion. Disproportionation. Oh, disproportionation. Sorry. Dispro. I'll explain it now. Disproportionation. Okay, now I'll explain. See, it is found that certain oxidation state of an element in a compound may not be stable. So in that case, what they do, they themselves lose and gain electron. That is, you do not require any oxidizing and reducing. They do some changes, and by this they will get a state where it will be stable. Say, suppose you are coming from market and you have put maximum weight in one of the bag, and other bag is empty. So you find that you are feeling uncomfortable to walk. So what do? You transfer some of the items from your bag to the other empty bag, and you try to balance itself. So in that case, what has happened? The empty bag which you had, now it has something, and the filled bag, now it has have less something. So same thing happens in element. So we'll write down what is the definition of disproportion. If some of the oxidation state of an element in a compound is not stable, then they undergo then it undergoes mutual oxidation and reduction. So this is called disproportionation. To give two compounds in which the oxidation state of the element is lower and in other higher than the original. This process is known as disproportion. So see here, it was +3. So we know loss of electron increases the positive oxidation state and gain of electron lowers the positive oxidation state. See here, in one of these, from this 3 molecules of nitrogen, one of the nitrogen has lost 1 electron each, so it has become 2 electrons. So it has become +5, and the 2 other nitrogen atom has taken the electron. See, this is +3, +5 is more than +3, and +2 is less than +3. So this is the one. This is called disproportionation. Both the reactions are important for your exam.